Hello, everybody, and welcome to our June 28th webinar on PhotonMax, our horticultural lighting solutions line of products. And now to introduce Paul Gray, our Senior Director of Horticultural Sales, to tell you about our products.
All right, thanks, Matt. This is a great day to kind of go ahead and start and talk about our PhotonMax, our horticulture lighting solutions. One of the things we're going to be covering today as we look at our agenda, we're going to be talking about some educational information in terms of some vocabulary, just general things we need to know when we're talking about a horticulture lighting solution. Also looking at different types of applications and sales opportunities. We'll also cover our product overview. We'll go through some information in terms of our marketing material. We'll also have Max Struck talk about our applications and lighting layout support, along with rebates. And then, of course, we'll close out with some closing points and then, of course, some Q&A. First off, though, when we start talking about our general terms and metrics, what I'll do is I'll go through some of the vocabulary points down here and talk about why they're important to understand when we're looking at horticultural lighting opportunities. And first and foremost, the first part we'll talk about is PAR light. Essentially what that is it's a photosynthetically active radiation spectrum, which is a range of wavelengths between 400 nanometers and 700 nanometers. Why this is important is because this is the foundation for driving photosynthesis. So many of the things that growers are looking for in terms of the weight of their crops produced or any type of qualitative, pretty much anything that happens in terms of growth with plants is driven around photosynthesis. So ensuring that we have the right spectrum of light is very important in the products that we offer. P-bar is kind of a critical portion of the spectrum outside of PAR, which is predominantly focused on the UV range and then also the far red region beyond 700 nanometers. And this is where these wavelengths drive many of the qualitative responses in plants that growers are looking for. So it's something that we also will assess at the time of discussing what our potential clients' needs are in terms of lighting as to whether or not we're going to focus on this area of the spectrum. Now, as we transition more into then the intensity side of light, we have the PPF, which is the photosynthetic photon flux, which is the rate of flow for photons in the PAR band. This is essentially a metric in terms of understanding the amount of photons that are being emitted from your fixture. So a lot of times in spec sheets, you'll see the PPF number talking about the output of the fixture. Now, when we go into the actual space or into the actual grow space, we'll look at the PPFD, which is the photosynthetic photon flux density. So this is now a light measurement of intensity that we take at, say, the plant canopy to understand what is needed to drive that growth that you're seeking in terms of various crops. So this is a very important metric. A lot of times you'll ask the grower, what is your PPFD requirement? Essentially, what is your intensity requirement at the plant canopy? Now, beyond the intensity, there's also the photo period. So this is essentially the amount of time that the lights will be on, so which is also a very important metric to understand because many times, let's say with leafy greens and crops that are similar, the amount of hours that the light is on is going to absolutely impact, say, their economic feasibility of their project. So, and we'll get into more depth into that a little bit later on, but it's always important to understand what that photo period is when you're dealing with various crops. And then there's also the daily light interval. This is a part where we look at how much light is being applied to the plants over a 24-hour period. And this is also an important metric when we start talking about greenhouses because many times what we'll do in greenhouses is the lighting that we will provide will be supplemental to the already ambient light coming from the sun. So then we take a metric of how much light over a 24-hour period the plants are getting. And so these are some of the terminology that you're going to want to have when you're having these discussions with growers and trying to figure out their needs. As we continue on, we'll also look at the photosynthetic photon efficacy. So that's where we start looking at micromoles per joule. So this is where we start looking at what the efficiency of the fixture is. And so micromoles per joule is really kind of the number one metric of understanding how efficient a fixture is, which is then ultimately will determine the economic feasibility of a project as whether or not the opportunity or the growers have the budget to afford the lighting that they're trying to seek to meet their needs. When we also get into kind of the spectrum and then also the intensity of light that we provide, there's some other things that can happen when you couple spectrum with intensity, and that's a term that we use where lighting can affect the morphology of the plant, which is what we would call photomorphogenesis. So essentially what we're doing now is we're using lighting to adjust the height, thickness, the texture of various crops, whether it be leafy greens or creating a very vibrant red tomato. These are some things that we can do with lighting to help with that. And then to the right, when you're looking at the screen here, we also have a spectral distribution graph. This is something where it can give you a visual to understand what the spectrum would be that we would be offering based upon the fixture type. And then last, we also have kind of a general terminology that is typically used in terms of where we talk about different stages of growth. The different stages of growth at times can require very different lighting applications. Not all the time, but many times it can. So we'll refer to it many times saying, okay, do you need lighting for clones or seedlings, for vegetative growth, or are we providing lighting that is focused on driving a healthy fruiting or flowering response in plants? So as we look back on these two slides, a lot of these terms are just going to be terms that you want to familiarize yourself with so that moving forward you can have the appropriate conversation with the grower. Now, beyond that, when we look at this next slide, we're going to talk about metrics for evaluating a horticultural lighting solution. So as I said, your PPFD, your micromoles per joule. Fixture form factor is also an important metric to also look at. Sometimes the environment that the fixtures that you're placing into that growing environment, there may be certain requirements. So if it's a vertical farm, the fixture profile may need to be very minimal, very slim, being able to fit itself in very tight spaces. Or if we're looking at it at a greenhouse application, you need to make sure that that fixture is not oversized, which can then result in a shading effect where you're canceling out the light that you're trying to provide because the fixture is too large. So fixture form factor can be a very important thing to look at. And then the spectral composition, what we also look at is how the light that we're applying, as we mentioned before, can drive photomorphogenic responses. Can we provide an additional layer of quality, say, response in secondary metabolite synthesis? So we're talking about how do we drive a certain response in a plant to produce a certain chemical? And then lastly, probably one of the most important metrics is how can our spectrum, how can our intensity of light drive the most amount of biomass possible, which is typically the number one metric that growers are seeking. And so when we do all this, we also have to make sure that it makes economic sense. And so we'll also look at various economic metrics to really make sure that, one, we can not only just provide the result that they're looking for, but do it in an economic manner. We also will look at the light spectrum benefits to plants. So many times in horticultural lighting, you'll see spectra that are heavily focused in reds and blues. And the basis in that is that while our eyes, our human eyes, are most sensitive to green light, plants respond with a high level of effectiveness in the red spectrum and the blue spectrum. And that's where we can say generally in the red spectrum promotes flowering, blue promotes very prominent stem and leaf growth. So when we start coupling those wavelengths together along with the green spectrum, it kind of creates this very efficient, very effective spectrum for reaching our growers' needs. We like to say that when we take just these wavelengths of light, it kind of is a type of scalpel approach where it's very precise. And then we can broaden it out to where we look more towards a broad spectrum that may include various other wavelengths, including at times UVA and UVB as well. So if we start looking then at some of our fixtures that we do offer currently for our horticulture line, we do offer a complete set of HID solutions. So one of the first fixtures we'll look at is our 1,000 watt double-ended high-pressure sodium complete fixture. It is a passive cooling design. It has a very high efficiency ballast. And it does have kind of a soft dimming where there's different set points that you can have the fixture set to. We do have a range of voltage options. It also has a PPF, as we talked about before, the photosynthetic photon flux, talking about those photons that are being emitted out of the fixture where that is sitting at higher than 2,000 micromoles. So this kind of creates a complete package. The high-pressure sodium fixtures are fixtures that people in the horticulture lighting industry are very familiar with, so it's something that is kind of a tried-and-true fixture technology. Our fixtures also offer a 3-year warranty on the ballast and 1 year on the lamp. When we continue to the next HID solution, that is going to be our ceramic metal halide. It does also offer a full spectrum, as you can see in the bottom right-hand side in that spectral power distribution graph. Typically on the metal halide side, it does offer a higher proportion of the blue light. So as we talked about previously in previous slides, talking about some of those responses, a lot of times folks will use the ceramic metal halides more for the vegetative type of growth, whereas folks will use the high-pressure sodium more for the flowering responses, fruiting responses. They can use it for vegetative, and the reason they do that on the high-pressure sodium side is it does have a little bit higher proportion of red to the blue. But either way, when we look at the ceramic metal halide, it does have a high CRI. There is a UV spectrum present, complete fixture, ballast, reflector, lamp. And then very similar to on the HPS side, we do have a 3-year warranty on the ballast and then 1 year on the reflector lamp as well. So now, when we also look at beyond just the fixture, we also offer lamp solutions as well. So you see here on this following slide, we have a 315-watt ceramic metal halide lamp. We also have the double-ended high-pressure sodium. And then as we transition from the HID to the LED side, we do have this single-ended T8 lamp, which also is kind of a twist-in fit. It does have kind of, as I described earlier, more of that scalpel, more of that very efficient, safe spectrum where it's providing just the red and the blue, so that as we look at more of the specs on the T8 single-ended linear solution, we do have various fixtures where we can put it into kind of a 4-foot single-ended ballast bypass T8 type of setup, but also in multiple lamp configurations. So whether it's a 4-lamp, 6-lamp, or 8-lamp, so that we can meet those target intensity or that target, say, PPFD that we're looking for. Typically, you'll use your T8 type of setup in the clone, seedling, and vegetative stages of growth, mainly because it offers a certain level of intensity of light. Really, when we get down to the nitty-gritty of looking at specs, it's always about, are we providing the correct spectrum? Are we providing the correct intensity of light? And that's where I can say when we start talking about application support, that's the next step in the horticulture lighting sale that's so important. Max Struct, who is our inside sales and also our horticulture specialist, can definitely go into more detail about our application support. And I think that's where I will hand it off to him to have him kind of go through some of our information and slides discussing the application support side. Max?
Thank you, Paul. I'm going to dive in right away, get into MaxLite application support. So what we do with our application support is we provide photometric layout services for all of our network, where our application team works in AGI 32, one of the preferred softwares in the industry, and we have a dedicated team on staff where they're able to do layouts all the time for you. Typically, you'll expect anywhere from a 48 to 72-hour project turnaround time. If you do get all the information up front, when it comes to our horticulture layouts compared to our regular lighting applications, there is a lot of information that is needed, and it helps to get all that up front so that our applications team can be efficient in getting you a layout. And you can see off to your right that you have an example of one facility we did with our double-ended HPS solution. Going into our next slide, we're going to go into a room example of a vertical racking clones and tissues for a cannabis facility that we did, where you'll see different racking systems where we use one of our linear fixtures for a target PPFD of 150. That's the typical light intensity that you're going to see in seedlings or clones and the cannabis facility. With a 12-inch mounting height is what we did for this particular application. Approximate size was 2,500 square feet. This particular rendering is just a 3D view of the other screen that you saw on the other previous slide. Going to the next slide, we have a typical example of a stock or mother rooms for a cannabis solution. Going through the room summary, you'll see an example or opportunity like this where they're going to be looking for a target intensity of PPFD of around 500 micromoles for the vegetative or mother state for a cannabis crop. When you're looking at this particular drawing, you'll see that the white benches in there signify where the canopy typically would be and where the calculation would occur on this particular example. Going into our third slide here for applications, you'll see that you have our grower flower room options. We can see a typical range of 700 to 1100 micromoles. Really depends on the particular end user's goals and knowing, what sort of lighting scenario or system we're going to put in place, really kind of getting that light count down. This particular example shows a 25 to 4,500 square foot facility. Then we're going to get into a little bit of greenhouse crucial considerations. And when you're thinking about a greenhouse environment, you have to remember that it's not just supplemental lighting or the lighting that's going on. You have a lot of reliance on the natural sun patterns that occur. So form factor is crucial when looking into your lighting solution, and lighting plans are typically oriented at minimizing light shading to maximize the utilization of natural light. Typically, it's very important to understand the target DLI of your customer, and when getting that, target DLI, you also need to make sure that they understand the average solar intensity in their region per day, because this is going to help dictate the required necessary supplemental lighting so that they're not over or under their lighting solution.
And hey, Max, I want to jump in real quick and just add one more key point to the target DLI point. One of the things that we can also do when we look at how we assess this important factor is, if need be, we can also look at doing, as we would call, doing a lighting audit in the actual space or in the actual greenhouse, where we can take actual light measurements, understanding what they're receiving in terms of their sunlight within the greenhouse, and then also take lighting measurements at night if they have existing fixtures in the greenhouse space, to then understand what they're actually getting in terms of the lights that they already have installed upon, say, us doing a retrofit, and then evaluate those two different measurements to truly make sure that we offer them the most economically feasible lighting solution based upon the actual space that they're operating under. Many greenhouses will have different transmission rates in terms of how much actual light from the sun is being transmitted through the glass or the material that the greenhouses are made of, and that percentage of loss of light through that material can differ on a great level from greenhouse to greenhouse. So it's something just to add to what MaxLite is offering in terms of our horticulture lighting solutions, is at times it will be an in-field assessment as well. So just wanted to throw that out there as an addition.
Thanks, Paul. And then getting back into heating and cooling, definitely important to look at the region that you're in, because this is going to influence your lighting plan as well, because whether or not you choose HID fixtures, they give off infrared light, which actually increases the temperature on a plant leaf surface and can be a good thing in the winter months. While if you have a long summers or predominantly a warmer environment or climate, it's going to increase your cost for AC in the summer and can reduce your heating in the winters. Something just to be cognitive of when looking into a lighting solution for one of your customers. And then next off, electrical rates. Cost of electricity, either operating or to increase capacity, can definitely influence the lighting technology decision for your customer. And understanding whether or not they're looking to reduce that or just reduce their upfront investment is very important to know. And then we're going to get into our marketing collateral. We're ready to offer dealer banners, trifold brochures, and we have a new look for our data sheets. All of our collateral is ready upon request, and please feel free to reach out to your local reps for info on marketing collateral. And then, moreover, we also have a PhotonMax MICROSITE. It's going to be a complete horticulture dedicated portal. It's going to be a total product overview and a product info one-stop shop. You'll be able to download the data sheets, access product information all in one portal. So if your customers are not as familiar with the MaxLite brand in the horticulture sense, they have a portal where they can feel right at home. Next off, we'll talk a little bit about DLC and Asabi, some stuff that you need to know. For the lighting world, rebates have been what have driven the industry for a while now. And so naturally, with DLC getting ready to come up with their QPL this September, we had the June draft that was released that's coming up this July. And then Asabi has been the one who's actually been dictating a lot of the information that's been used to help DLC come up with their new QPL and standards. And Asabi has came through with 3 different standards that come out. The first 2 have been released. The third is still under review and consideration and should be released here within the next year. And that's going to be primarily to help dictate investigation of the quantities of light, recommended test measures for plants, and just completely understanding how to really evaluate a horticulture application. Next off, I'll let Paul get into some of the closing points.
Wonderful. Thank you, Max. So just to kind of wrap up, one of the things I think is so important to stress here is that the success that you can have in a horticulture lighting opportunity is really defining a lot of the metrics and all the information on the front end, essentially before any type of fixture is hung in the actual environment. So one of the things that we like to really focus on is identifying the application. Is it an indoor type of warehouse where the lighting is the sole source of energy for plant growth? Are we talking about vertical farming? And vertical farming can be a wide range of applications. Really, essentially, if we're talking about vertical farming, it can be any type of multi-layered propagation of crops. So there's a wide range of what vertical farming could be, but it is obviously very important, as we stated before, whether it be form factor of the fixture, spectrum, intensity of light, whatever it may be. And then, of course, last, we would say greenhouse. Greenhouse is one of the market segments that is very cost conscious in terms of meeting their lighting needs. So it's always important to understand all the metrics so that it makes sense for them to put the lighting in. And then, of course, identify the end user or customer's goals. Sometimes their number one goal is biomass. In other words, how much of their crop can they produce in terms of weight. Sometimes it's an operational goal. So in the example of vertical farming, sometimes if we can offer simply an extra foot of growing space within that vertical farming, that can be a huge factor in terms of how much of their crop they produce. Does that extra foot of space also allow their workers to harvest the plants more efficiently? So sometimes we have a wide range of goals that a particular grower may have, and it's really important to understand that. And then as the next point, meeting the ROI, the target ROI. Sometimes folks want to have the best and most scientifically advanced lighting solution provided, but at the same time, can they afford it? Does it make economic sense for them to put that lighting in the space? And so it's coming to that target ROI that can be so important. And then, like we said, identify the customer's performance metrics. What does a successful lighting application sound like to them? And with all that said, with all these different metrics, it can seem sometimes overbearing, but it's not. And with addition to that, you have the MaxLite horticulture team. So we always say at any stage, at any process, please contact us. We're more than happy to help on any of the different points that we've talked to today. And so with that, I know Max and I would just want to say thank you very much for listening to our presentation, and hope that any of your horticulture opportunities will have a chance to discuss it with you and move forward from there. So at that point, I guess I will just hand it off to Matt. Thanks, Matt.
I just wanted to remind everybody about MaxLite University, our lighting degree program. It offers 3 comprehensive courses in lighting fundamentals, ranging from beginner to advanced learning. It's free and eligible for the following continuing education units from the American Lighting Association: Lighting Fundamentals Intermediate, and Lighting Fundamentals Advanced. So please head on over to www.maxliteuniversity.com. Please follow MaxLite on our social media sites from LinkedIn, Facebook, Twitter, and YouTube. You can find everything you need about MaxLite on our social media pages. Thank you, everyone, for your attention. Please feel free to use this opportunity to ask any questions you may have about MaxLite or the products shown in this presentation. Have a great day.